To understand how these algorithms work, I will show that Metropolis-Hastings works because it satisfies detailed balance at a stationary distribution. Gibbs sampling will inherit this property if I can show that Gibbs sampling is a special case of Metropolis-Hastings with a proposal acceptance rate of 1. We begin with the acceptance criteria A using detailed balance. Pi is our proposed steady state, P is our transition probability, F is our unnormalized target distribution, G is our proposal distribution. We choose lambda to maximize either acceptance, which is equivalent to minimum of 1 over either F times G. Substituting lambda back, we have our two acceptance criteria. Notice that we do not need to normalize since we are taking a ratio of F. When the ratio is greater than 1, acceptance ratio becomes 1. Let Pxt be the probability we are at state x at time t. We multiply Pxt by Pxt plus 1 given we are at xt where xt plus 1 can be any state we can visit next. Using detailed balance, we set outflow at time t equal to inflow at time t plus 1 for any state. We have the trivial case where proposal is rejected and nothing moves. The probability to transition is equal to the probability from proposal distribution times acceptance criteria we saw earlier. We distribute the terms in and cancel out fractions. We do the same for the other side of the equation and see that both sides of detailed balance are equal. Suppose our d-dimensional target distribution has been factored into d univariate conditional distributions. The deterministic next sample is selected in d step. For every variable I, we hold all other variables constant and update from the ith univariate conditional distribution. X prime represents our proposed next state. Minus I subscript denotes conditional on all variables except I. Q denotes any univariate conditional distribution. We substitute Gibbs sampling proposal distribution into Metropolis-Hastings alpha. Rewrite the joint probability into conditional probability times the probability of the condition. Numerator equals denominator. The above holds for any one variable condition on all of the other variables. Therefore, it can be applied to any variant of the Gibbs sampling. This shows that Gibbs sampling is a special case of Metropolis-Hastings with acceptance of 1.